So this is negative 14 meters per second. Give people a chance to write down. The question to think about, what you have it written down, is what is the displacement from 5 seconds to 15 seconds? So during that last 10-second interval, what is the displacement?
Negative 14 meters per second.
That would not be the displacement.
Oh,
What was the question?
What is the displacement for this last 10 seconds? There are a couple ways of doing it. We can do it with area, or we could do it with the formulas. Both? Which one do you want to do first? All right. So we're finding the area of this triangle here. One half my base, which is 10 seconds, from there to there. And then what is the height?
Negative 14.
Yes, the negative becomes critical here. So when we talk about area under the curve, most people think under means below. In math, when you talk about area under the curve or under a line, it is the area from that line to wherever 0 is. So area under the curve is indeed under here, because it's positive, but it's over the curve, even though physically written on the board it is above the curve, but the language is under the curve. So negative 14 meters per second, which is negative 70 meters. Let's do the equation bit. I'm trying to find displacement for that last 10 seconds. So delta S, VI, VF, A, and T. My acceleration is still the same. That line has not changed at all, so my acceleration is still negative 1.4 meters per second squared. All right, what is time going to be?
10 seconds.
Yep. What is my initial velocity?
Zero.
Yes, because again, we're talking about here. We're starting at this point right here. And my final velocity? So we know 4 things here. And we're trying to find displacement. We have 3 equations. Oh, I forgot to do the second equation. We'll come back to it. Whichever equation just strikes your mood, it seems like the third one's the simplest here. And so this is going to be my average velocity, negative 7 meters per second, times my time, 10 seconds. So negative 70 meters. This negative 7 comes from 0 plus negative 14 divided by 2. We can double check our answer. Because for the first 5 seconds, my displacement is positive 17.5 meters. For this last 10 seconds, my displacement is negative 70 meters. So for the overall trip, for the entire trip, my displacement is just the sum of those two, which is negative 52.5 meters, which is what we calculated right there. a couple of takeaways here. One, there's more than one way to solve these problems, but if you solve it different ways, you should get the same answer. And I understand on a test or quiz, you don't necessarily have the mindset to go, hey, let's try it completely second way just to see if I get the same thing. That also is the double-edged sword of, if you do it two different ways and get the same answer, you should feel pretty good. But if you do it two different ways and get different answers, now you're left with, uh-oh, something went wrong. All right, I still haven't used that second equation yet. I want to use that to find my VF. That one right there. So let's do it. So VF squared is equal to VI squared, so that's 7 squared, plus 2 times my acceleration, negative 1.4, times my displacement, which is negative 52.5. This is for the entire trip. So that's 49 plus whatever that is. Somewhere around 150. Oh, actually. $147. So that gives us 196. So VF squared is equal to 196. So VF equals what? But the answer for my final velocity is negative 14. What happened to the minus sign?
Because it can be positive or negative since it's the square root.
From a math point of view, if VF squared is equal to 196, VF could be positive or negative 14. However, this VF actually is equal to positive 14 meters per second. What is this VF compared to that one? What is the difference between those VFs? Missed it. I thought somebody said something. What do you mean, coverage? What is the difference between these VFs? Other than one's squared and one's not, the actual VF itself. What does that VF represent and what does that VF represent? What does that line over the top mean?
Scalar and.
Not polar. It's a very important word that I will be using throughout the entire course.
Vector.
Yes, that's the other key word.
What was it?
Scalar and vector.
Yeah, that's a vector, that's a scalar. So since this is a vector, what does that V represent? What's the word? Or we can do this one, whichever one you want to do first.
One gives direction, right?
Absolutely.
But that's not what we're doing.
No. The vector gives direction. That's why we had a minus sign there. Because that minus sign tells me the direction it's moving in. This V is for velocity. Sorry to spoil it. What does that V stand for? hint, it's not velocity.
Speed.
Yes, that's speed. When we derived it, we did a dot product. Dot products produce scalars, and so that's when the vector symbol dropped away. It is important for you to know the difference between velocity and speed because, well, at least on a purely this class grade kind of thing, on a test, if I ask for the speed or if I ask for the velocity, I'm not necessarily asking for the same thing. Well, no, change that. I'm not asking for the same thing. One has direction, one does not. All right, questions before we do the part about when I ask you, what is the distance traveled?
So as a shortcut, couldn't you take, like, if the final velocity, if you're trying to get the final speed and you have final velocity, could you just, if it's a positive final velocity, then it'd be the same, it'd be the exact same answer as final speed, right?
They would be written the same, yes.
Yeah.
In this case, since it's negative, it's officially the scalar is the absolute value of the vector.
Okay.
All right, so what is the distance that this object traveled? Assuming it's one-dimensional motion. Let's do a visual here. We have an object, so let's say up is positive. An object starts somewhere, because that's what objects do, they start somewhere. It starts out going in the positive direction, 17.5 meters. At 5 seconds, it stops and starts moving in the opposite direction. So after 5 seconds, my velocity is negative, which means that it's traveling in the negative direction at that point. How far does it travel in the negative direction?
Negative 17.5.
And then keeps going.
Oh. Is it the negative 70 there?
Yeah. So it goes 17.5 meters in the positive direction, and then it goes negative 70 meters, or I guess 70 meters in the negative direction. So that it ends up 52.5 meters in the negative direction. Displacement is where an object is relative to where it started, so that negative 52.5 means that it ends up 52.5 meters on the negative side of its starting point. So displacement doesn't care what happens in between, just cares about where am I relative to where I started. But the distance traveled, we're now dealing with scalars, the distance traveled, well, I went 17.5 meters this way and then 70 meters back. What was the distance traveled?
87.5 meters.
Yep. And so the distance is 87.5 meters. And that should help address one of the problems the questions you asked me earlier about. So. You can pretty much be sure that on the first test, there'll be some question where I give you the data, and I'll say, what's the displacement, what's the distance traveled? All right, questions before we start doing a couple of other examples here? That will no doubt make you feel like more of a complete human being. Because that's what physics does. All right, I guess I'll start erasing down to this end. Is traveling at 30 meters per second. And then accelerates uniformly at negative 6 meters per second squared for 10 seconds. What is final velocity of the car? What is final speed of the car? What is displacement of the car? What is distance traveled? Whenever faced with a problem like this, we start out with writing down what we know. What do we know?
Time,
All right, what's time?
10 seconds.
Yep.
Initial velocity, 30 meters per second. Acceleration, negative 6 meters per second squared.
Okay. Now, there is an ambiguity in the way I've written this problem, and I shouldn't have done it, but I did it anyway. I say the car is traveling initially at 30 meters per second. There's not really clear whether that 30 meters per second is a speed or velocity. So I can make sure that it's clear that it is a velocity one of two ways. One way is I just put a plus sign in front of it just to emphasize the fact that it's in the positive direction, or I would actually write out is traveling at, lost the word initial, at an initial velocity of 30 meters per second. All right, so first question I asked is what's the final velocity? I also want to point out on the test, sometimes it's that last question. I mean, I had still one of my favorite tests. It's basically one problem, 14 parts. Ideally, if I looked at the last answer and the last answer was correct, then you got all the parts above it. So, with one exception. No one got it, unfortunately. That would have been really easy to grade. So when I break it down into parts like this, oftentimes I'm breaking it down into parts in the order in which I would solve it. That doesn't mean you have to solve it in that order. We could actually find displacement first before we find the final velocity. But just to give you an idea, when I break it down, some problem down into parts, it's usually, that's just the order in which I'm doing it. If one part requires use of a previous part, then that's the reason I did it that way. But sometimes students do it out of order, and if you do it out of order, that's fine. Just, it's helpful to draw a few arrows just to know, so I can follow your line of thinking. All right, so I'm trying to find final velocity. Which equation should I use?
The first one first.
Okay. My recommendation is that you write down the equation to start with. I know Ms. Sasson requires it. I don't require it, but yet. But it's really helpful if you write down the equation, so I know, again, so I can follow your line of thinking. So we have VF equals 30 plus negative 6 times 10, which is negative 30. Units.
Meters per second.
Questions about how we got negative 30 meters per second? All right, what's the final speed? What's the final speed?
30 meters per second.
Yeah. Just ignore the direction. So this is negative 30 meters per second, and this is just 30 meters per second. What is the displacement? What equation would we use to find the displacement?
Third equation.
You said third?
Yeah.
Okay. So I got delta S is equal to VI plus VF over 2 times time. And so I have 30 plus negative 30 divided by 2 times 10.
Zero.
Finish it out.
Meters per second.
You went too far.
Oh, meters.
Yeah, meters. What is the distance traveled? It is not 0.
It's, 30 and negative 30, so.
Not 30 and negative 30. All right, first off, let's address the 0 thing. The displacement of 0 means the person or the car ended up at the end of the problem exactly where it was at the beginning of the problem. Ultimately, over the entire course of the problem, it didn't go anywhere. Net result, it didn't go anywhere. When I'm asking for the distance, so imagine that you're in your car, you check the odometer in your car, you drive to school and then drive back home. ultimately you are exactly where you ended up at the end of the day, where you were at the beginning of the day. But I'm asking, what is the change in the odometer reading? What is the actual distance that was traveled? Pardon?
I wanna say 60.
Why do you want to say 60?
Well, if you're going 30 in one direction, and you're going back
Just meters per
again
second.
in 30, then 60, I guess, I don't know.
Yeah, that's two things there. It starts out going 30 meters every second.
Oh, right, okay, yeah.
And so if it did 30 meters every second for
10 seconds.
for 10 seconds, that would put it at 300 meters.
Yeah.
However, it doesn't maintain that the entire time. At some point, it does turn around.
Okay.
Let's throw that in there. At what time does it stop? Because if I'm going in the positive direction and then the negative direction, I have to go through zero. Nature does not like objects jumping from one direction to the other direction. Except in the movie The Fly. Or no, it was the Simpsons Take Off on the Fly. Let's solve for the time. So we know displacement, we don't know for this is the stopping. We know VI. Acceleration is -6 meters per second squared. And we're trying to find time. We do know, I have only two pieces of information here, so I have to know a third one. What is the third piece of information?
The final velocity should be 0.
Yep. So how would I find time?
Second.
Second one doesn't have time in it.
Oh, I'm sorry.
And in case, I guess, it kind of looks like I have 5 equations up there, so let's get rid of that.
You got the first one?
First one.
Yeah. Now let's say that you're on a test or quiz and suddenly your mind blanks. Not completely. If your mind blanks completely, then, well, not much you can do at that point. But you're having difficulty figuring out which equation to use. You could just plug into all of them and see which one has time as the single unknown. But the first one is indeed it, so I have 0 is equal to 30 minus 60. There's my math problem. So -30 is equal to -6t. T is 5 seconds. Which makes sense, there's some symmetry there. So how far does it go in the positive direction before it turns around? In other words, since I'm only traveling in one direction for this first 5 seconds, there's no turning around, so the distance traveled in the positive direction is the displacement. Which equation would I use?
You can use the third one.
Okay. So that becomes 30 plus 0, so it's my displacement, over 2 times 5. I could figure out what is the displacement for the second half, but I don't have to because we have all the information there already. It starts out at some point. It goes 75 meters in the positive direction. I know at the end of the problem, it's gone nowhere. the end of the problem, it has to be back where it started. So if I went 75 in the positive, I went 75 in the negative. My total displacement is 0, but the distance traveled is,
50 meters.
yep. Questions to there? Let's take a look at this from a graphing point of view, because everyone loves a graph. Right, acceleration versus time. What does the acceleration versus time graph look like? Well, the thing goes for 10 seconds, so I can mark that off. More than I wanted to do. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So at time is equal to 0, what's the acceleration?
Zero.
Nope.
When the time,
At time is equal to 0,
time's equal to zero.
what is the acceleration? When the problem starts, that's time is equal to 0 when the problem starts.
So negative 6 meters per second squared.
All right, so I'll put meters per second squared in parentheses there, put a negative 6. All right, what about at 1 second? What's the acceleration?
The same.
Yeah. At 2 seconds. What's my acceleration versus time graph look like?
Horizontal line.
Yep, it is indeed constant. That's the key word right there. Velocity in meters per second versus time. What does that graph look like?
The initial is 30.